Another interesting compounds of boron is borazine. This borazine is also called as inorganic benzene. So please write the structure of benzene. So you know molecule formula of benzene, it is C6H6 and this is the structure of benzene. And the borazine, in previous classes we understood the preparation of borazine. That is when diborane is react with ammonia. So it gives B3N3H6 and it liberates 12 molecules of hydrogen gas. This B3N3H6 is a cyclic molecule and the structure resembles the structure of benzene. That's why it is called as inorganic benzene. So here, we studied several reactions. That is, boron react with ammonia, it gives different product. The nature of product obtained, it depends on the stoichiometry of diborane and ammonia which is used during the reaction. So here, if we use diborane and ammonia in 1:2 ratio, so you are going to get borazine. And so you just look at the structure of borazine and benzene here. So here benzene has 3 pi bond, 1, 2, 3, it has 3 pi bond. Similarly, the borazine also 3 pi bond, 1, 2, 3 pi bond, and it has the pi bond present in alternative position. Here also pi bond present in alternative position, and the geometry, and it has hexagonal shape and it has also hexagonal shape. That's why the borazine and benzene are isostructural. That means both possess same structure, isostructure. That's why they are called as isostructural and isoelectronic. Isoelectronic means if you count the number of valence electron in each carbon atom. Okay, here each carbon atom has 4. Okay, each carbon atom has 4 valence electrons. So totally there are 6 carbon. So 6 into 4, 24. So it has 24 valence electrons. Similarly, here each boron has 3 electron and each nitrogen has 5 electron. So from boron, so there are 3 boron, 3 into 3, 9, and there are 3 nitrogen. So 5 3s are 15. So you please write and 24. That means both has same number of electron. Dear students, so once again, if you cannot understand, so write the structure separately and count the number of electron, valence electron, not entire electron, only valence electron. So carbon has 4 electron. There are 6 carbon. 6 into 4, 24 electron. And so in case of boron, there are 3 boron. Each boron has 3 electron. That you know while discussing the structure of diborane. And nitrogen has 5 valence electron. 1s2, 2s2, 2p3, 2s2, 2p3, 2 plus 3, 5. So totally, 9 electrons from boron and 15 electrons from nitrogen. So 24 electron. Because of same number of electron present in borazine and benzene, they are called as isoelectronic. And so it has planar hexagonal structure and both has same number of pi bonds, alternative double bond, and same number of valence electron. That's why because of resembles in the structure, so this is called, and this is an inorganic compound. That's why this is called as inorganic benzene. Borazine is called as inorganic benzene. Its formula is B3N3H6. So let us see the preparation of this borazine. This borazine can be prepared by 3 methods. The one is Stokes method, by eating with boron trichloride and ammonium chloride, and eating with lithium aluminum hydride and ammonium chloride. That is, so the first method is when diborane is react with 6 molecules of ammonia, okay, under minus 120 degrees centigrade reacts. Okay, this is important. It gives dimerized product. Beginning, it gives dimerized product. After on eating this compound around 200 degrees Celsius, it gives B3, B3N3H6, and it liberates 12 molecules of it liberates 12 molecules of hydrogen gas. Okay, it gives borazine and it liberates 12 molecules of hydrogen gas. This is the first method, and this method is called as Stokes method. That means, so if you heat the diborane and ammonia in 1:2 ratio, first it gives dimerized product. This dimerized product means exact bond formation do not take place, just they are intact together, and finally on eating around 200 degrees Celsius, it gives borazine, a cyclic molecule. It resembles the structure of benzene. This is the first method. Second method, on eating with the boron trichloride and ammonium chloride. When ammonium chloride react with the boron trichloride, so in the presence of C6H5, that is chlorobenzene, so it gives derivatives of boron, okay, so plus 9 molecules of HCl, and this chlorotriborane is again react with 6 molecules of lithium borohydride. So here lithium borohydride is a reducing agent, I told you, because it gives hydrogen to the reactions. That's why it is called as reducing agent, and this is a reduction process. It gives B3N3H6 plus B2H6 and 6 molecules of lithium chloride. That means, so this is borazine. So on eating boron trichloride and ammonium chloride, so it gives one intermediate chlorine product, and so this chloroborane on reduced with lithium borohydride, it gives borazine. So this is another method of preparation. Next, we can also prepare this diborane by eating lithium aluminum hydride and ammonium chloride. So when 3 molecules of lithium aluminum hydride react with 3 molecules of ammonium chloride at 275 degrees Celsius, it gives borazine B3N3H6 and 6 molecules of hydrogen gas liberated, and 3 molecules of salt, lithium chloride salt, is generated. These are the 3 methods in which we can prepare inorganic benzene. Next, properties of borazine. As I told, the borazine is called as inorganic benzene, and it possesses some of the properties, which resembles the properties of benzene. For example, and this borazine, when we come to the chemical properties of borazine, this borazine is highly reactive compared to the benzene. Why? Because in benzene you have seen that only carbon is present, but in case of borazine, boron is present and nitrogen is present. That is more electronegative species than carbon, and active boron is present. It acts as Lewis acid. These are active species compared to carbon because of presence of active ring member. In benzene, all the ring members are carbon, but in case of borazine, the ring members are boron and nitrogen. Because of presence of active ring member, the borazine is more reactive than benzene. So you look at the reaction here. A small correction is there. Instead of B3, So, uh, so this is borazine. When this borazine reacts with three molecules of HCl, it gives chloroborazine. Okay, this chloroborazine further on eating, it gives trichloroborazine. This is trichloroborazine and liberates three hydrogen gases. This is addition reaction. Okay, so borazine undergo addition reaction, that is react with three molecules of HCl. So finally it gives trichloroborazine. So, dear student, if you want to understand, you write the cyclic structure. You write the cyclic structure. In the cyclic structure, exactly at in alternative position. Alternative position means like this. So this is boron. So nitrogen, boron, nitrogen. Okay, in alternative position, so double bond is there. Okay, and there are 6 hydrogen present. Okay, each boron and nitrogen attached with 6 hydrogen here. So the chlorine atom, so there are 6 hydrogen in the borazine. In the 6 hydrogen, the chlorine replaces 6 hydrogen. It replaces 6 hydrogen and it forms a bond, that is 6 chlorine attached to boron. So this is a addition reaction. And similarly, I am writing the general formula, molecule formula. So if you want to understand, you write the cyclic structure of borazine. The reaction is same as that of benzene. So here borazine react with 3 molecules of bromine, Br2. Okay, bromine is a liquid non-metal. So it gives an unstable molecule, and later actually it is Cl6. So unstable molecule, further it undergo decomposition, it produces tribromoborazine. Here trichloroborazine, here tribromoborazine, and it gives 3 molecules of hydrogen bromide. Another property is hydrogenation. So benzene gives cyclohexane. On hydrogenation means reduction. So reduction means addition of hydrogen. If you add hydrogen to any organic molecule, so if it has double or triple bond, the double bond, triple bond compound convert to single bond compound. That is unsaturated compound convert into saturated compound. Similarly here, so B3, borazine react with 3 molecules of HCl. So you know that it gives trichloroborazine. So when it reacts with a reducing agent like sodium borohydride, so it gives B3N3H12. Okay, so you see here hydrogen atoms are added and double bond are vanishes, so it gets single bond and it gives diboron and sodium chloride. So and hydrolysis, borazine react with 3 molecules of water, so it gives 3 hydroxyborazine and it liberates hydrogen gas. That means 3 hydrogen get replaced by OH group, which is supplied by hydrogen. So these are the chemical properties. So there are 3 important chemical properties: addition reaction, hydrogenation and hydrolysis. Hydrogenation means addition of hydrogen. So it is also called as reduction. So this reduction can be performed in the presence of sodium borohydride. And hydrolysis, that is water molecule undergo breaking and added to a molecule. So it gives trihydroxyborazine. So these are the important chemical properties of borazine.